Mohammed can actually come in. Okay. I guess we need to wait for people to come. There, we have someone attending. Someone walked into the room.
Yeah.
Let's give just a few more seconds for people to switch over.
Yeah.
So maybe our first presenter, why don't you start your screen sharing already? We are ready.
Yes. Can you guys see it?
Yeah.
Okay. You let me know when I can start.
Let's get started since it's 6:01, and when Mohammed comes, I'll pass on the baton to you. So please go ahead, Isabella. All right. So thank you all for coming. We are starting our session, which is Evolution and Maintenance 3. Our first talk is why do projects join the Apache Source Foundation? The talk will be given by Isabella Ferreira, and she has 5 minutes. The way we are doing it is we'll have all the talks, each 5 minutes, and end of all the talks, there'll be question answers. And as you go through each of the presentations, please feel free to write out the questions on the chat. And when you write out the question, please add the prefix, the name of the presenter, so they know who the question is for. So without further ado, Isabella, let's get started.
Hello, everyone. My name is Isabella Ferreira, and I'm a PhD student at Polytechnic Montreal in Canada. And so let's get started. So it seems that over the years, there are more and more software foundations hosting open source projects. And often by joining these foundations, these open source projects need to donate their source code and follow the rules set by the foundation. And this actually triggers a question of why do these projects actually want to join open source foundations rather than operating by their own? And understanding the reasons behind the decisions for joining software foundations can help us to understand what open source projects expect from software foundations, and also to help software foundations to provide a better assistance and a more inclusive environment for open source softwares to grow. So in this study, we investigated the motivations for joining Apache. Apache is one of the world's largest open source foundation, and by studying this foundation, we hope to learn more about the motivations from different kinds of open source projects. So we investigate 3 research questions. First, we studied the primary organizational and geographical characteristics of the donated projects to understand the diversity of such ecosystem. We then studied what motivates these projects to join the Apache Software Foundation, and answering this question provides an overview of the expectations from open source projects for software foundations. And next, we studied to what extent these projects have different motivations. So understanding the similarities and differences among these projects can actually help software foundations to optimize and prioritize their services and assistances. So in Apache, every project with the intention to join the foundation has to submit a project proposal which states their technical and non-technical background, motivations, goals, and their status. We studied these questions by conducting a qualitative analysis on 292 project proposals. And based on our analysis, we found that America-based projects are still dominant, but there is a growing trend of Asia products since 2016. And the main contribution of this study is the derived motivations from project proposals. In total, we have identified 28 motivations, which are grouped into 10 high-level categories. And here I'd like to highlight the most common motivations, which are related to community, outcome, interactions, and technical development. So it is expected that projects would like to foster their community with the help from the Apache Foundation. And secondly, we also observed that projects that would like to increase the impact, visibility, and foster innovation, which are not discussed in previous studies about open sourcing software foundations. For our third research question, we found that there are more company-based projects in Apache. However, companies and non-companies projects, they have roughly the same motivations for joining the foundation. So with the results from RQ2 and 3, we suggest that foundations should focus on meeting the common expectations from different open source projects, helping them to foster their community, increase user base, and improve outcome, interactions, and technical development. And since we have seen an increased number of Asia-based projects in recent years, we suggest software foundations focusing more on providing tools and techniques that can support communication and interactions between projects coming from different cultural backgrounds or using different languages. So for example, some projects may require additional assistance in adopting English as their main language for communication. And for researchers, we suggest to further help open source projects to better decide whether joining a foundation could be beneficial for them. And for that, researchers should, for example, study the effectiveness of incubation in software foundations as the next step. And an interesting study would be to see what kind of guidance and governance open source software foundation provide, and also to what extent were that effective to help projects achieve their goals. And thank you so much, and I'm happy to take any questions.
Thank you, Isabella, for a great job. Our next presentation is by Alexei Turcot, and it is DR Async, and it's Dr. Async, Identifying and Visualizing Anti-Patterns in Asynchronous JavaScript. Alexei?
Cool. Thanks. So yes, I'm Alexei, and I'm going to present our tool called Dr. Async. This is joint work with Mike Shaw, Mark Aldrich, and Frank Tipp at Northeastern, and Mark's now at Tufts. So I'm going to ask that you put yourself in a JavaScript programmer that wants to write some function to recursively copy a directory. So the first thing you might do is import file system and path resolution modules using the JavaScript require statements. Then you might define a function, an outer function CP, that first checks, all of the stats of the source. If it's a directory, we'll call a function cpdir that we'll write. And if it's a file, then we'll just use the copy file utility from fsdirect. Then we might define our function cpdir, which first checks, okay, if the source is directory, let's make sure the target directory exists. If not, create it. Otherwise, let's get all the files in the source directory, iterate through them, resolving any paths, and then call our outer CP function. Cool, so we are satisfied. We have created a function to recursively copy a source directory to a target directory. But we can actually do better. So you'll note here that we used all of the synchronous APIs from FS, but there's nothing inherently synchronous about this task. We could use the asynchronous API instead. There are many ways to do asynchronous programming in JavaScript, but Dr. Async is focused on promise-based asynchrony, so I'll just quickly overview that. Promises are essentially abstractions around asynchronous computations. So for example, if we have fs.lstatsync, this sync function that, let's say, gets a stats object for a file, the promise-based asynchronous version would instead return a promise that eventually file stats will become available. So in terms of type here, the type of the second call would be promise of stats. To make use of that asynchronous object, we can actually use the await expression, which was made available in one of the latest ECMAScript versions of JavaScript. So here, this is called fspromise.lstat, gives us a promise of stats. And what await does is await will tell JavaScript, okay, go execute other things while this computation happens asynchronously. And then once it is done, we'll unwrap this stats object, and then in this case, equal to stats. Caveat here, await can only occur in async functions. So if we had a function called dir exists that returned a Boolean if a directory exists, the async version of that function would instead return a promise of a Boolean. So you can imagine how this kind of change would infiltrate like your entire program. So back to our example. here we've written our CP_dir function, except in the asynchronous way. So you'll see that we're using all the promise-based APIs. We're awaiting those calls. We've made our functions async to actually have those awaits. And since those are async, we have to await calls to those. And again, now we're very satisfied. Wow, we have an async version of copy_dir. But we can actually still do better. The key observation here is that each loop iteration, while we're awaiting this call to CP, will wait for each file in that directory to be copied before continuing. You want to think about this in terms of the lifetimes of the underlying promises, the duration of the underlying asynchronous computations. The first call to CP would create a promise. That promise would resolve asynchronous. We're waiting for it with the await expression. Then it would end, and only then would we issue the subsequent calls. And this is over-synchronization. Like in this case, there's no state, so there's nothing inherently synchronous about this. This should not be synchronous. Instead, we would like to see many overlapping promise lifetimes, because that would mean many asynchronous computations are happening at the same time. It turns out that the refactoring for this is quite simple. So instead of having a for loop, we would instead just map over all the files in a directory. And then instead of awaiting the promises, we're just going to collect them into an array. And then we'll use the promise.all functionality, which if we wait that, it will just wait for all the promises in the array to resolve before then continuing. This allows many of these copy requests to happen at the same time, and we are truly happy. So this is an example of one of the 8 anti-patterns we report on in our paper. The paper also has more details on a visualization tool that visualizes these promise lifetimes, relations between promises. We have a simple static analysis that detects these anti-patterns from code. And we don't automatically refactor them, but we have a case study of manual refactoring and a general evaluation, which finds thousands of promises in JavaScript projects. So thank you for your time.
Thank you, Alexei. Great presentation. Now let's get our next presenter on track. Our next talk is by Hongjae Ye, Knowledge-Based Environment Dependency Interference for Python Programs. All right, Hongjae, whenever you're ready.
Slide? Yes,
Yes.
I'm ready. Okay, let's begin with my presentation. Hello everyone, I'm Ye Hongjie from Institute of Software, Chinese Academy of Science. Today I will introduce our paper entitled Knowledge-Based Environment Dependency Inference for Python Programs. Python is one of the most popular programming language, and it has achieving an active ecosystem. Thus, people usually reuse a Python code to improve their development efficiency. To reuse a Python code, people can find code snaps from Stack Overflow or GitHub Git. However, such snaps may be not runnable because the code snap is provided without its dependencies. But it seems easy to reuse the Python program. User can first install a compatible Python version and then install all the dependent third-party Python package, and after that, the user can run the program. However, inferring dependencies for Python program is non-trivial. Firstly, standard modules and syntax features restrict the compatible Python versions. And secondly, third-party modules indicate the dependent third-party package, and module names can be inconsistent with the package names. And thirdly, system libraries are important transitive dependencies. Lastly, a package can be required by others at the same time with different version constraints. Users should carefully choose a proper version. To this end, we propose a knowledge-based approach to infer dependencies for Python programs. First, we extract and collect domain knowledge from multiple data sources, and then construct a knowledge graph, PYKG. Then we propose a knowledge-based approach to infer dependencies for Python programs. Given a Python program, we first extract its features and then infer dependencies with the support of the constructed knowledge graph. This is our knowledge graph model design. It portrays the features of the Python interpreter and third-party packages, and it also portrays the dependencies among the Python interpreter, third-party package, and system libraries. We collect and extract knowledge from multiple resources. We analyze Python documents and convert syntax feature into regular expressions, and analyze directory structure to extract modules in different levels. And we analyze metadata files to obtain the compatibility and the dependencies. Finally, we propose a similarity-based mining method to discover dependencies between third-party packages and system libraries. Finally, we construct a knowledge graph containing hundreds of thousands of entities and millions of relations. In stage 2, we propose a approach to infer dependencies for Python programs. Given a Python program, we first extract its features. We extract module features by program analyze and extract syntax feature by regular expression matching. Then we query PYKG for dependency candidates from a target program-centric subgraph which portrays the interrelations among the candidates. Then we determine versions of the candidates while constraint solving. To avoid dependency conflict, we propose 3 constraints. And to achieve the best solution, we propose 2 requirements. The final solution contains the proper versions of dependency resources need to be installed. To evaluate the effectiveness and efficiency of our work, we propose the following 3 research questions. And we evaluate our work on the 3 datasets. The experimental result shows that our work reaches 46%, 62%, and 61% accuracy on the 3 datasets. And compared to pre-request and Dockerized Me, we reach the highest accuracy and install the least third-party package. However, we infer more system libraries. In conclusion, we propose a knowledge-based approach to infer dependencies for Python programs. The approach contains 2 stages, knowledge graph construction and runtime environment generation. That's all. Thank you. I'm looking for your questions.
Thank you, Angjay. Great work. And this brings us to the last talk of the session. And our presenter would be Chen-Jie, and the paper is called Online Summarizing Alerts Through Semantic and Behavior Information. And again, ask you all, if you have questions bubbling in your mind, please ask them here in the chat so we can get started on the Q&A after this talk. Otherwise, we'll just keep staring at you all. All right, let's get started. There you go, Chen.
Can you see my slide?
Yes, we can see. We are seeing the presenter mode, not the presentation. Might have to switch. Yes, awesome.
Okay. Hello, everyone. I'm Jia Chen from Fudan University.
We can, the sound is very light. Can you come a little closer?
Can you hear me now?
Better. Can you make it a little louder?
What about now?
Yes, nice. All right.
Hello, everyone. I'm Jia Chen from Fudan University, and the work I'm going to share is online summarizing alerts through semantic and behavior information. In a real scenario, a failure usually triggers multiple alerts due to the interaction between system components. And although maintenance engineers commonly define some correlation rules to summarize alerts of the same failure, and thus reducing their workload, but it is hard to cover all correlations by manually defining correlation rules. And this is an example. All these 5 alerts, in fact, are triggered by a NTP start error. To correlate alerts, we find that alerts belonging to the same failure have similar semantic and behavior information. For the semantic information, in this table, all the contents of the alerts describe the same anomaly from different perspectives. And for the behavior information, the alert of E1 and the alert of E2, we construct their occurrence series by counting their frequencies per 1 minute in a day. And we can find that these 2 types of alerts occur in the same time periods, and the fluctuations of the 2 series are similar. And therefore, we propose an online alert summarizing approach, OAS, to summarize alerts into incidents, and each incident contains alerts of the same anomaly. OAS has three major components: ASR, ABR, and ACT. ASR not only mines the contextual information of each alert word, but also considers the contribution of each word to the overall alert semantics. And for ABR, it captures the commonality between a current series of correlated alerts by a neural network, and ACT measures the correlations between alerts by aggregating the semantic and behavior features from ASR and ABR. And here is an overview of our approach. Our approach has two stages, training stage and summarizing stage. In training stage, we first pass alerts to get alert content words. In this step, we pass alerts to remove parameters in contents, and then we remove stop words from alert contents. After that, we group alerts into different types according to past contents. Then we calculate the occurrence series for each alert. We calculate the number of alerts of each type per alpha minute in the past beta minutes. Then we train the semantic representation model ASR and the behavior representation model ABR. ASR and ABR have no dependency; they can be trained separately. Finally, we train the alert correlation model ACT to measure the correlation between alerts by the semantic and behavior information from ASR and ABR. The alert correlations for training can be retrieved from history video reports written by maintenance engineers. In summarize stage, we summarize the newly reported alert by time window. For the newly reported alert in summarize stage, we similarly preprocess alerts to get alert content and occurrence series. Then we can directly extract the semantic and behavior information of the alerts by the representation models ASR and ABR, which are trained in the training stage. And we can measure the correlation between the newly generated alert and the previously reported alerts during the time window. According to alert correlations found by ACT, we summarize the newly reported alert by appending the newly reported alert to an existing incident or constructing a new incident for the new alert. And that's all for a brief introduction to our work. Thanks for your listening.
Thank you, Kenji. Well done. And a round of applause to all our presenters. And one thing I missed mentioning is our second talk, the Dr. Async by Alexei, has actually gotten the Best Artifact Award. So congratulations, Alexei. Yay. So since our real session chair has not shown up, I, Anita Sarma, and Fabio are sharing our chair responsibilities. So I will hand over the chair baton to Fabio.
Yeah.
Fabio, take it away. I gave you the hard one. I took the easy one.
No problem. It's, I was in the other session. Now I moved to here to help to sharing with you. It's a nice pleasure to stay. And absolutely great talks, great work. And you have a lot of time to do a great discussion. So maybe you can start by your question, Anita, because you did. For Isabella, did you see any differences in motivation between projects that were in Asia versus US-centric ones?
So yeah, that's a very good question. In fact, we conducted the Fisher exact test to see if there is an association between a project having a specific motivation to not having the specific motivation and projects from America and non-Americans. We compared the continents and we didn't get any statistical significant result. And the same for the type of organization. But since we could not find any correlation, it seems that at least in our sample, the continent and organization are not relevant variables to see these differences. We did a association mining rule mining, and we found that projects that also want to build their community, they also want to gain diversity and enlarge their user base. So, but yeah, roughly it's the same for projects from different continents and organizations.
Super interesting, huh? Because sometimes intuitively you imagine there is some differences, but interesting points. Absolutely. But maybe you can continue with you, Isabella, just to progress in a second question by Hideki. So how does one open source software project decide which foundation to belong to among the many foundations? That is a good, interesting question. Huh?
Yeah, that's a very good question. We didn't compare the motivations we found with from projects of other open source foundations, but we did find that around 45% of the analyzed projects, they want to join the Apache Software Foundation because of the Apache Way. And what is this Apache Way? It's basically an established development process that Apache has. They have like a meritocracy model, and they also aim to have self-governed open source communities. So I would say if a project aims to have those things, to follow the Apache Way, Apache would be a good foundation for them, among the other motivations that we've seen.
Could I follow up on this, Fabio? So this is very interesting. You said 45%, right? Almost 50% are trying to go to the ASF because of the Apache Way. In a survey we did with the Apache ASF contributors, I think one of the big barriers people had said that they had problems contributing to ASF was because of the Apache Way, because it's a great philosophy, because it's meritocracy, anybody can join, and we need to have everyone's voice in, but it also means like it's very flexible and it is very fuzzy, right? There is no clear way or example or template because they don't want to specify a particular process, right? And that causes so much confusion that they don't know what to do. They think this is the Apache Way, and then they say, no, it's not. So there's a lot of confusion. So did you see anything about that, or?
Yeah, in fact, we analyzed the motivation. So this was more about like projects were interested, as you said, on the philosophy of Apache. And that's what they wrote in their proposals. But actually, we didn't measure if they achieved their goals in practice. And I think that would be a very interesting study in the future to see if, okay, I want, as a project, I want community building to have achieve the Apache Way. Did I really get that after, I don't know, the incubation time or not? That would be very interesting to see. Because if there is this barrier, yeah, maybe it's more about the philosophy and yeah.
Super interesting. I read your paper before. The thousands of papers, I read yours because super cool.
Thank you.
So I have one question for Alexi before to continue with Isabella, because Alexi, it's super interesting work that you did, but I wonder to imagine that could you generalize, you think, to other languages as C# or Rust, there is async features?
Certainly.
To generalize?
This is certainly a thing that you could generalize. Off the top of my head, as you mentioned, C#, they have the same like async await kind of idea.
Mm-hmm.
I think Java also has that kind of functionality now. One interesting thing about JavaScript is that the way that asynchronous programming has evolved, I would argue, in the last decade, go from like events and then like callbacks and then promises and now async await.
Mm-hmm.
I feel like developers are really confused about how to, write async code, which led to a lot of these anti-patterns occurring. But I think it'd be really interesting to expand this to other languages, specifically also because static that we do detect like instances of patterns in code. You could write a much better analysis in a language that's not JavaScript, or for a language that's not JavaScript. Like there's way more information, for example, in Java, and I'd imagine in C#. But yeah.
Absolutely amazing. You know, I work on software visualization, and why you didn't submit to Vsoft? It's super welcome to Vsoft, your work. We really, really love to receive your work in Vsoft. But okay, it's in ICSI. Okay, no problem. So,
well, if we
it's not too focused. Put this work in Vsoft. I'm sorry. So congratulations, super! I loved your work, super. And I imagine that also to create some plugins to VS Code, developers will love maybe to be more in, because you did a prototype but not a plugin for VS Code. That's it.
Correct. Yeah.
Okay, because you know one of the most. Sorry. No, I just say that the most downloaded sometimes plugins in VS Code. There's not the most downloaded, but there's a lot of attention for visualizations in VS Code. It will do a lot of success if you submit as a VS Code plugin your work.
Great idea. Thank you.
So I have one question to Hongji. I'm sorry for the pronunciation. Yes,
Hey, Fabio, could I actually tag on to the visualization question for Alexei?
Okay, yeah, sure.
Yeah, since we're on the talk already.
Anita did one.
So
go ahead, Anita.
Yeah, so I'm looking at the visualization you have, and I'm finding it pretty complicated. So my question was, did you try it out with anybody who's like a user of Python or a developer, maybe a newcomer versus someone who's been doing it for a while, and see if they understood like what this anti-pattern was and how to fix it?
That's a great question. Fortunately, the answer is easy. No, we did not do a user study, but I can offer some tidbit of experience. So the story of this project was, we had the idea to develop this visualization just to try to understand how the asynchronous, like how these promises were being executed and how worked out. And so the viz came first, and we just ran the viz on a bunch of, we ran the profile on a bunch of code. We looked at the visualizations for a lot of code, and that kind of led to the development of a lot of these anti-patterns. So we've used it a lot, but certainly I imagine if we polished it up and then added some more features and then did a user study, that would be really interesting.
That's a Vsoft paper for you right there.
Absolutely.
There you go. There you go.
Let's go to Vsoft. And Mathieu, I will do your question. You will do. Don't worry. Mathieu is the best attended award in the ICSI. He's everywhere. So and do a lot of questions. So, but I have just to do a round with Yongji, because Yongji, I have one question for you super quickly to say, because you try to analyze the dependencies and the cycles, and what do you imagine to produce something to analyze vulnerabilities or try to connect vulnerabilities with your work?
Can you speak slower? I cannot follow the question.
Sure. My point is about security. Imagine that you have security issues in one package. How we imagine to use your tool to analyze these vulnerabilities or security issues to propagate and to analyze?
Okay, I see. As for security, we do not consider it at now, because we do not consider security now. But I think it will work in the future, because there's many security informations such as license or others on the in the metadata of a Python package. Maybe it will work. Maybe we can collect such information and store it in our knowledge graph and analyze it in the future.
Sure. There is a paper in the previous session that I was chair, and session chair too, that guys did using NPM to analyze NPM codes. To exactly that you did, but using NPM to analyze vulnerabilities in JavaScript, in JavaScript nodes. So that's why I imagine that you have a good opportunity to maybe to merge this effort to try to improve this part of vulnerabilities.
Yes, I think it's a good idea.
Super, super cool. Congrats. This is a huge work to do. So super important work. Congrats to the choice to do this research. And Matthew, please do your question. Matthew is the best attended award in the ICSE. Do your question to Isabella.
Yeah, I did my question as Anita was asking hers, and I think it ended up being very similar. I was curious if Isabella, you saw some projects that joined Apache but then regretted it. But yeah, I think you pretty much answered it already. I don't know if you want to expand on it.
Yeah, maybe just so the projects we analyze, they're still part of Apache Incubator, so their proposal was accepted and they're still there. They didn't retire or left the foundation for any reason. So, and I don't think they would express their regrets in the proposals we analyze, but I think that would be definitely interesting to analyze, maybe analyzing the discussions on the mailing list. And yeah, I'm not sure if that would be really visible, but one other way would be to survey or interview the Apache developers or owners of projects. Yeah.
Super interesting because, you know, I'm a big fan of Apache Foundation. I love this way that try to do. What do you imagine, Isabel, that maybe to, I not say more inclusive, but sometimes it's hard to come in. You say this takes time to a project come into Apache. There's an incubation. There's a, I'm not say a bureaucracy, but is a ceremony, I can say, to come in. Do you imagine that's something to become an impediment to come into Apache Foundation? Or can say what, maybe elaborate better to say what maybe Apache, what in your vision Apache Foundation could improve the process to admission for new projects, maybe?
Yeah, didn't really analyze the barriers that projects face, but I think Anita has a paper on that, so maybe she can comment on it.
Found like the barriers to joining the ASF, and one of the few things, right, was this Apache way itself, because it was confusing, and there was a little other problem where Apache is still like, it's started from a volunteering based, everyone is democratic kind of a thing, and now as more and more companies want to join, there is this kind of pushback against companies. So there is a little bit of a friction between companies and Apache, and it takes a long time for you have to have at least 2 or 3 external companies involved, because one of the things Apache Way wants to do is that there is not a single company monopoly. So a company comes in, starts a project, and it's an ASF, but it's really that company. You have to have at least 3 other companies, or 3 companies, plus some volunteer-based contributors. And that process of getting enough people started, the incubation time is kind of not great, because it's not that they cannot move forward. They have to do some PR and get other people in. So I think that was one of the big barriers for companies starting in, and for just regular contributors, right? That's the whole bunch of barriers that we have talked about for newcomers. So there are a lot of strategies, and we are hoping that I'm actually consulting with the ASF now, trying to see how to get them to improve the diversity and inclusion. And one of that is
Right.
to how to reduce the barriers for newcomers to enter, and how to move things a little forward faster. And while we were doing the survey, how we wrote the survey for this, one of the contributors, like, one of those people with the veto power, said, "Oh, you don't know what the Apache way works. This is not how we work." I'm like, nobody understands the Apache way, including us. So to me, it seems like everyone has their view of what the Apache way is, especially in the those in the board of directors. And it's good as a philosophy, but without making it as a template, it's just hard. So I think that is the good point and the bad point of the ASF.
And that's very interesting because you talk about the community, the diversity of organizations, and we found that around 51% of the projects, they mentioned community diversity, and most of the projects, they mention diversity of organizations rather than geographical nationality diversity. And I'm wondering now so they write in their proposal what they know that Apache wants. So Apache wants projects with from different organizations. So they write that in the proposal as a motivation, so they can have the proposal accepted. Yeah, that would be interesting to see.
Sure. Because
Hey, Fabio, I'm going to leave this room and do my backup sharing in the other rooms for the next session, and I'll come back if everything else is there. Okay.
Thank you, Anita. And
thank you, Fabio. Teamwork.
No, yeah, absolutely. Because if Anita is not there, you don't have the chair. So Anita is the backup chair because your official chair don't show up. And I'm a backup chair. So I'm here just to help you. But Alex, one question for you. What's the challenge that you did when you tried to propose your visualization, and did you, especially for representation, and you try to, I think that you have a time sequence that you did, but what's the origin of the metaphor and that you proposed? What do you imagine that you could maybe do something different, or maybe you try to elaborate differently?
Yeah, I guess so. The main thing in the visualization is those bars of promised lifetimes. I didn't really touch on this in the talk overview, but there's more information available in the viz than just those lifetimes. So for example, promises in JavaScript can be chained. So you might have a promise and then register reaction on that promise that will itself create a new promise. And that information is visible in visualization. The way to get that information, the async hooks API for Node.js, it's this dynamic analysis profiling thing that tells you a lot of information about promises being created, destroyed, resolved, who caused the promise, all that kind of stuff. And then I think I know Anita's not here anymore, but touching on her earlier question about like people maybe being confused about like what to do about these anti-patterns. There's we tie the promise, like the dynamically created promise, like the bar in the viz. You can see the code that created that promise, which is also like a nice like useful feature. And you can see the promises that are created from anti-pattern code. So there's certainly a little bit more to it.
Yeah, but I cannot read completely your paper, but you did some experiments to evaluate the visualization with developers.
So like the paper didn't really evaluate the viz too much. I think the main thing is in our case study where we did the manual refactorings visualization, for example, prioritize which refactorings you want to do. were 10 entities in a project, but one of the anti-patterns had like 3,000 promises related to it, then we would fix that anti-pattern to see if there was like a benefit, if that makes sense.
Great. Yeah, I love the idea to introduce these anti-patterns for async in the Java. Super cool and absolutely nice.
Thanks.
And we have well, it's your question, Alex, to Gia.
It is.
Could you
Yeah,
do
I'll ask it. So I get the idea that you know, there's a lot of confusing error messages when like some related thing. I'm just wondering, you know, they write a program and then it crashes and then there's like 300 lines of output that's like written to the console and it's hard to say like what's going on. Do you think your approach could work for sending error messages in that kind of scenario as well? Sorry.
You're mute.
Oh, sorry, I can catch on your words. Can you slow down?
Sure. I'll ask my question again. Basically, your approach to summarizing error messages, do you think it could apply to like confusing error messages in other like domains, like outside of the context of alerts?
Sure. Our approach, in fact, is a general approach that can be applied to most scenario. If there if the alert had a timestamp and a contents, then such alert can be, our approach can be applied to such alert, no matter the alert from any applications.
Okay, cool. Thanks.
Thank you. Isabella, maybe a provocative question, but what's the future of open source software?
Wow,
you?
that's a deep question. In which sense?
Yeah, that means that you are thinking that the future is around big organizations, big foundations as Apache, and more companies working around, or is more as ad hoc and independent, or it's a hybrid that's space for everyone? What's your vision long term for open source movement?
Well, my point of view on that is that companies will start to open source their projects more and more, and we are already seeing that. Like Google, Microsoft, they have a lot of their projects already open, and I think projects, maybe even from organizations, but let's say from individuals or researcher labs, that they don't have the resources or the knowledge to make their projects grow themselves, they might need to join a foundation. But I think the trend is that companies will open source more and more their projects because that have many benefits for them, such as innovation, people developing new things for them and things like that.
Because, I have a vision that in the future, in the infinite, every software will be open source.
Yeah, I hope that happens.
In the end of the day, in the future, in the limit of the time is infinite, every software will be open source. It's inexorable. Because in the end, it's the progress that's open source in the end.
Yeah, I
think not a short term, in the infinite.
Yeah, but I think we are on that way already. We have a lot of open source projects already helping in big projects, such as for green energy or things for like climate change. So I think it's a fast way for people to develop their projects, and yeah, I think that's the way to go.
And the infrastructure will be, because I started to work in open source and using Linux in 95. So in the 95, everyone say, "Oh no, open source is bullshit." No, don't worry. It's just no one will do that. And now everyone uses the open source. And
Yeah, it's still one of the biggest projects with most contributors.
yeah. So I'm just it's a huge pleasure with stay with you here. But if you don't have more questions or comments or observations, and our audience, no more questions. So maybe it's a good time to cheers and close our session. Congratulations another time. It's a great pleasure to stay with you this night here. And I hope to see you in other sessions in ICSE tonight. And I hope to see you in Montreal, Isabella.
Yeah,
And,
nice to see you here.
I work with Bram and the guy, so nice to see you in Polytechnique. And I work in ETS, so you are neighbors.
Yeah.
So thank you so much and see you. Bye-bye.
Thank you, everyone. See you.
Thanks
Bye-bye.
all. See ya.